Hello, everyone. Welcome to our presentation. My name is Alina, and as you already probably know, our vision is to raise the bar of technical excellence across the world. Here is our organizer team, Valentina. She is founder and organizer at Tech Excellence. Daniel, Oliver, and myself, we are co-organizers and co-hosts. Here is a list of our speakers of next month. Stay with us. You can follow us on different social media platforms such as Meetup, YouTube, LinkedIn, X, GitHub, and Discord. Our sponsor is Optimum and our partner is QE Unit. So, today we are happy to introduce Jimmy Bogard. Jimmy is a well-known conference speaker and the creator of the popular libraries Automapper and Mediator. He's an independent software consultant based in Austin, Texas. He also invented the vertical slice architecture, which is also the title of his presentation today. But before, I would like to remind you, you can leave your comments and questions anytime in the chat down below. And at the end of the session, you will have a 30 minutes time slot for discussions. Enjoy the presentation.
All right, thanks, Alina. So this talk is really a description of my journey in software development, sort of me building systems with other teams throughout the years, and over the years trying to figure out what kind of architectures really make sense in my head and also make sense for my teams as we build out bigger and bigger systems. When I first got started building applications, building kind of traditional client server systems, you got a UI, you got a database. The sort of the state of the art at the time was in-tier architecture. And that sort of traditional look was something like this, where we have a user interface layer, and then that talks to a business logic layer. That business logic layer can talk to a data access layer, and then that data access layer then talks to the database. And the idea here is that each layer can really only talk to the layer below it. And as long as I could kind of figure out where each of my, if I'm adding a new feature to a system, then if I could figure out which one of these layers any bit of logic could go, then that should result in a quote kind of good system. And in fact, when I first got started in development, this was even for Microsoft, the architecture they recommended. So their how-to articles and things like that would put out these kinds of systems to say, this is how you should organize your application code and organize your logic. Now, we started to notice some issues with this kind of architecture, namely that it could produce not so easy to maintain code. And so at the time, I was looking towards other luminaries in the software industry to understand this kind of organization works okay for smaller systems, but as systems got more complicated, it kind of fell down. And so that's led me to looking towards DDD, or domain-driven design, which I guess greatly improved on this sort of tiering of logic, where instead of we used to have a business logic layer, instead we have something called services, and we would then have something called a domain that was our business, main business logic, and instead of a quote data access layer, we'd have a repository. Now this, for me, wasn't too terribly different than our previous in-tier architecture. Like instead of a business logic layer, we'd have the services and the domain, and so it's kind of more separated than we had before. And instead of a quote data access layer, we'd have the repository, but otherwise it still functioned as our data access layer. So while it was kind of slightly improved from the previous in-tier, it wasn't significantly better or significantly improved. And so at this time, you started to see folks try to expand on these ideas. It's saying, okay, we need better ways to organize our code and our application, and especially to have more stricter rules between how different areas of the code can talk to each other. And so at that time, I was on one of the teams that was really pioneering one of these styles of architecture to be really prescriptive at how different code should belong in different areas. But it wasn't the only one out there of different ways of kind of providing rules about exactly which code should belong where. So some of the other popular ones out there at the time, and kind of still going strong, on the upper left there we have the onion architecture. named so because it's like concentric circles as you get lower and lower down. And then on the right there, we have hexagonal. Most folks looked at onion and said, hey, isn't that the same thing as a hexagonal? And it is mainly, except it's rounder than the hexagon. So I guess it's different. And then finally, at the bottom, you have clean, which again is very, very similar to the onion architecture, very kind of prescriptive guidance, especially in the .NET world about, which you have a very specific guidelines of how you should structure projects, and then very strict rules about which kinds of projects and the directions of references and things like that. So I was on a team that really took this kind of layered approach to its extreme. We were on a very long-lived system, long-lived application, actually headed up by the guy that invented onion architecture. So we thought we had the kind of the best chance to succeed with this architecture. And then we had a set of purported benefits that's basically, here's the things that you will get out of using this kind of architecture. Things like it'll be independent of frameworks. So you are creating abstractions between you and some other frameworks. So you don't have direct dependencies on these other frameworks. And those frameworks could be, loggers, DI containers, ORMs is a big one to say, I don't depend directly on the ORM, just in case you switch it off for something else. But you create these abstractions between your application logic and these other quote dependencies. We were also told that it's supposed to be very testable. So you can very easily write unit tests, which is true. But we also found some downsides to this approach as well, specifically in the form of the tests that were coming out of this. And the big thing about these architectures is independence. So making my application logic, my domain logic, independent of quote outside concerns, whether it's user interface database, like other third-party dependencies or other kind of outside concerns outside of my application that are supposed to be independent of all these different things. So in this long-running application and system, we put all of these kinds of concepts and ideas to the test. So we had cases where we needed to expose our application logic to different user interfaces. We even had cases where we needed to incorporate other databases and other outside dependencies. And over, we found that when we actually put these kinds of benefits to the test, that the verdict was not true, that these didn't actually provide those overall benefits, that the logic was not independent of the database, that there was hidden coupling we found all over the place. And in the cases where we tried to pretend some things didn't exist, it actually made it much more difficult to change things in our system. So in this project that I was a tech lead of, one of the things I was trying to understand was when a new developer comes on, or we have a new feature needing to be developed in the system, what are all the things the developer needs to do in order to add that feature into the system? And the idea was that, with this very strict layering approach, I needed basically an instruction manual to developers to say, here are all the places in the code base that you need to go change in order to add a feature to the system. Because it was not obvious whatsoever to new developers, if I need to change something in the system, where do I go in the code base in order to figure out where that, where are those changes that need to be made? And in this application, these kinds of architectures, almost always it's organized by layers. So we would have some kind of person domain model or data model, depending on how much behavior's in there. And then the different kinds of capabilities I would expose for that object would be exposed in object-specific layer objects. So I'd have like a person controller for the UI tier. For domain service logic, there'd be a person service. And for all the data access logic for that thing, then there'd be a person repository according to that. And so if I was going to make a change in the system, I would have to go through all these different objects to add or modify code accordingly. And so we took this to the extreme and saying like, okay, now I've got this repository object that has all the data access logic in my system for that one single table or one single domain object. And then it got kind of crazy. And this is actual code that I wrote, so I have only myself to blame. But when we were building these applications that would create these abstractions on our data access layer and creating these layer objects that were then the place where all that logic was supposed to go, as systems grew, these layer objects would grow and grow and grow and grow over time. You notice at the bottom, it cuts off the code. So this went on for like another 2 or 3 pages, where just like anytime I had to add additional data access logic, it would always be going into this one single class. And so you might have different things for these kinds of objects. You know, I've seen things like, if I have orders in my system, I'd have an orders service or an orders manager or an orders helper, which is basically the dumping ground for any kind of logic related to that domain object gets dumped into this kind of one file and just grows and grows and grows over time. The other major challenge that we found was just navigating to the code base to understand if I need to make a change into the system, what are all the areas we need to touch in order to make that change happen? So when this is even just a flattened hierarchy because it's not even different projects, but in order to make a change in the system, we found ourselves having to hop all over the code base to make that individual change. So I'd have to go to the controllers to go modify the initial entry point to the application, but the views were way over here, the business logic was way over there, the kind of screen logic was over here, the data access logic was way over there, and there weren't any sort of rules or notions of how any of those different pieces were related together. They were just all kind of organized by type as opposed to organized by areas of change. The other major challenge we saw was coupling. So in this kind of architecture, we had controllers that would then talk to application services. Application service could talk to domain services. But there wasn't any rules about kind of which could talk to what. And so if we looked at the coupling diagrams of what classes talk to what classes depend on what, and what classes do those classes depend on. So looking at the coupling of everything, we found it just created kind of a spider web of nastiness where really anything could call anything one layer below it, but that also meant and introduced a lot of coupling. And I couldn't even fit in this diagram here because there's just too many arrows going along. But we also had the case where classes inside a service could also depend directly on classes also within that same layer. So we would have, like in this picture, a person service could call anything from the student service at any time, for any point, for any reason. There were no rules saying like, okay, does this logic here, is it intended to be used in other places, or is it only intended for one very specific use case? So with these layered approaches, there weren't really any boundaries to say this set of logic really only belongs to this one specific use case, or this one specific screen, or this one specific user operation. It's just in a spot in a layer that could be used by absolutely anyone. And because the organizational structure didn't explicitly tell the developers that these are intended to be separate and not used for anything else, the design of the classes, the designs of the objects didn't lend towards that kind of idea that this is one for one specific use case. Instead, we ran into this where methods and classes were being called for just about anywhere, which meant that if I make a change to one of these methods that has a bunch of arrows going into it, it greatly increases the chance that that logic will break the other consumers. So after the end of this project, this was about, 2 or so years I was on this project that made a very large onion/clean architecture style application with very specific rules and strict rules about which layers can talk to what, but didn't enforce any rules about coupling between any sort of classes. We got to the end and said, this has been, we thought it was going to be some sort of salvation to say, all a developer has to know is about, based on the logic, which layer that belongs to, which is okay. But once you get kind of past the sort of surface level set of logic you have to add, becomes much more complicated to understand. If I need to make a change in the system, how does that affect the downstream consumers of this class and this object? So we actually got to get a redo. This next project I was on, which really gave birth to this idea of the vertical slice architecture we're talking today, It didn't start out with vertical slices. It started out with nothing. So my colleague and I, who had lived through this kind of layered nightmare, said, okay, we don't know what the right architecture should be at all, but let's just throw out all of these kind of sacred ideas, because they didn't seem to be giving us a lot of benefits. And developers coming on the team, like the tech leads and architects, really liked it, because I guess this, we spent a lot of time like crafting this very perfect architecture, but the developers hated it. No one liked working this code base. It was very convoluted and difficult to explain. So he said, right, I don't know what it should be, but let's throw out everything. Let's throw out all these different ideas and concepts. Let's start from zero, and then we will let the architecture emerge from the patterns we are seeing in this application and build architectures around optimizing for those patterns versus trying to be very upfront and prescriptive about the different patterns we see there. So what came out was us looking at this application and seeing that really in this system, we could kind of break down the application into two kinds of requests, two kinds of operations. It wasn't a bunch of layers and things like that. It was just like there's two different kinds of things you can do in the system. In this web app, it was basically you have gets and posts. It was a get action, which you were reading data from the system, and these actions are safe and idempotent. That's the idea behind gets. And then we have posts, and the posts are forms that we put on the screen. They click a button to perform some operation, and these actions are unsafe and not idempotent. But if you notice these two are basically opposite of each other. We have get actions that are querying data in the system, and then we have posts that are then commands to do operations in the system. And these two kinds of actions that you're performing are very, very different in the code that you write, the heuristics that they're under, the transactional guarantees, like they're completely different and opposite from each other. So around this time when we were seeing like, okay, we had jammed these two concepts into these layer classes that try to do both. Around the same time, Greg Young came at this idea of saying, okay, you're creating these layer classes, these services, repositories, managers, whatever. They're doing these two very different kinds of operations. Why don't you split those two things into two different classes with two different concerns? And that gave birth to this idea of CQRS, which is the Command Query Responsibility Segregation Principle. And simply put, it is two models or two objects where once there was one. Now, this idea has been greatly expanded over the years. So folks do things like put event sourcing in there and like view read-only databases with like projections from event models, things like that. But that is just variations on a pattern of CQRS. At its core, CQRS is just simply two models where once there was one. So we saw this and said, you know what, this makes a lot of sense for us because there's not really any code shared between our read and write paths in the code base. So initially we just started out with literally just all code in the UI tier, and then took a step back and said, okay, what are the different things we're seeing with these two different kinds of requests? So looking at our original layer objects, we saw this, that we have these queries that represent different, very specific means of getting information out of the system. And we also have commands as part of this as well. There are more commands, but they're just like scrolling down further to the bottom. But we've jammed all these different queries commands into these single kind of monolithic layer objects. And when I want to make a change in the system, I'm having to go through all these different layer objects in order to affect that change. So if I'm adding a new screen to the system, I'm having to go to the UI layer, I'm making a change in the domain object, I'm making a change in the service objects, I'm making a change in the repository, I'm making a change in the database. So the sort of axes of change is more on a vertical, gonna go see where this is going now, is more on a vertical slice versus going across a single layer object across the entire system. So as we were making changes to the system, we saw that this idea of organizing logic around the horizontal layers didn't make much sense because that's not how I actually changed logic or added logic in my application. I was always doing something like adding a new screen. Well, that meant a new controller action, new view, new API endpoints. I needed to add maybe some new domain objects, and new logic in the different sort of tiers of my application. But the organizational structure we had initially didn't lend well to this, the way we were actually changing code and actually adding logic to our system. So we said, forget this. We're not going to organize our logic anymore into these horizontal tiers that just cause merge conflicts and cause all sorts of coupling. Instead, we're going to optimize for how we actually change the code in our system, which is we're adding new features one slice or use case at a time. So that led to, initially it was just feature folders that we would organize our application logic into feature folders, but it grew more into this idea of an architectural style around this organization of our logic. So in this, we are in this style of architecture, we're modeling and organizing our application architecture around the axes of change and areas of cohesion, which are these vertical slices. So what are these vertical slices? We started out with just looking at the application logic we needed to change across the system and saying, for one individual request, let's take all the code that is related to that request and move it to a single place. So this is like a single location on disk, so that if I was looking to understand how a specific action was being performed in the system, everything related to all the different kind of areas of change or areas of concern would be organized together on disk all together. So in our old way of organizing, where we had a domain service or application service around entities or aggregates, but each of those methods was only ever being called in one individual action the user is performing. So we said, why organize all these together? Instead, move all these different areas of code out into their own individual classes. So when I'm looking at what is all the logic related to a specific operation to perform, I don't have to worry about all the other things that can go on as part of that slice or part of the entire system. Instead, it is physically separated out into its own individual location. So this is where we started. We simply said, let's take the CQRS idea of, we take a service object, we break the service object and the repository object into its own individual smaller objects that are only related to that one request, and each of these is just in then one place on disk. We iterated on this for quite a while, but started to notice that each of these individual, I was going to say microservice, let's not use that word. Each of these different smaller service classes, don't like micro domain service classes that are only for one specific use case or only one for one specific operation, start to look very similar to each other. And the similarities weren't necessarily intentional, and it certainly wasn't by design, but we started to notice that like these different services didn't need to look different necessarily. They probably could look the same, and if we modeled them the same, then we may get some additional benefits out of this. So we started to take that CQRS concept even further to say, let's model these commands and queries as first-class citizens in our application architecture. So instead of having just kind of a mishmash of different domain or application services that represented the commands and queries in our system, let's represent command and queries as first-class things in our application architecture. So we wound up with an architecture that looks something like this, where we would have an input into our system, and this represented some user inputs or some external inputs. We would wrap that up into a single class that was the input for some operation. That operation would then be handed off into some handler for that request, and then these requests represented both commands and queries for information to do or to do something in our system. And then optionally, there would be some output of that as well. And the idea with this is that there would be one input going to one handler that would result in one single output. So I would not try to have like potentially different inputs or sharing different things. Each of these different request handling input output pairs would represent a single slice or a single use case of functionality in the system, or really a single operation the user is performing. We did this enough. After a few projects, my boss at the time got annoyed that I was copying code everywhere. And so he said, why don't you can you pull this out into an open source project, a NuGet package, so we don't copy the paste this code? And this is really where Mediator came from, is the idea that I explicitly model this input and output as a pair. So a request is always paired with some response. And then there's a single handler, a class, that knows how to take the requests and produce a response. And so this is modeled by a single method. You have a handle method that takes a request, and then you return, of course, it's async await, so I return a response. So looking at our application now, we had a way of modeling all of the requests and responses, all the different commands and queries in our application. So in our web application, we'd have the request coming in for a query, and this would result in our web application basically delegating off into a single sort of slice of functionality that would take that query, delegate that to a handler that would then return the response. And the response would then be whatever I showed on the screen, or hand it off to some other transformation. So translating that response to JSON, translating that response to HTML. The idea is that it's just data int to the handler and then data out from the response. Similarly, in the post side, the input would be a command object, some kind of command DTO, that again would get routed to some handler for that request to do something that would then result in then that response. And it was always one model in and one model out. One of the things we found with our kind of bespoke service classes was some of the service classes would have a single parameter that would represent all the things, all the pieces of information in one sort of object. But then some of them would not opt for that. And they would just say, okay, we'll have method parameters, we'll have multiple parameters. But there was no real rhyme or reason about why a developer would pick one over the other. And so we wanted to standardize on that and say, for our system, for our applications, we will represent all the information going into a specific handler for a request as one object coming in. And then all the information needed to respond to that, whether it's showing data on a screen or telling you the result of the operation, with results and then a single response object. So the standardization just meant it was one less decision developers were having to make about how to model the interactions. We just said everything that you need to do should be put into this one single object going in, and then everything that's needed on the way out should be modeled in this one single response object on the way out. And by the way, if anyone is familiar with like functional domain styles, like a lot of this is heavily borrowed from their concept as well. We can't do a lot of other functional things, so this is more of an object-oriented view of this kind of architecture, but it's something certainly as we were building out this style, that we heavily leaned on the lessons learned from the functional folks to be able to model these kinds of systems. So that handler, though, the intention there is that we provide complete encapsulation for everything that needs to happen for whatever that operation is, what it needs to perform. So it's more of a black box that I send a request in, the handler completely decides how it needs to perform the logic for what it needs to do. And then from the application perspective, it produces a response. But from an application perspective, I don't care how that all comes together. All I know is I pass in a request, magic happens, and then I get a response. So looking at the areas of change, we were used to be hopping around all over the place to be able to do all the different kinds of operations for any one individual request. So what we wound up doing is trying to collapse all this down into a single location. So in this one, I'm showing a single file with like nested classes. You don't have to do this. It could be a single folder. The point is I'm taking all the things related to an overall feature and then putting them in one single location. So the DTO coming in for the command, the validation logic, the handler logic, Any other kind of ancillary logic that is part of this one single request then is in one single location on disk. And so it starts to become where you can collapse entire features down into either one class, one file, or one folder on disk, depending on how big each of these different pieces go. So how do we model this explicitly? So the first one we'll look at is queries. So I'm looking at an individual application and trying to migrate it towards the style architecture. The first thing I'm looking at is, okay, well, how do I model this initial request object coming in? So this is an unfactored controller action that is doing some more complicated querying. So if I'm looking at, okay, what are all the inputs in order to perform this operation? These are going to be the query parameters that are up here in the controller action parameters. And so I would want to take all those input parameters and then model them as properties on a single class. Some of my queries are very simple. So if you think about like an index or home page, there may not be any other parameters for those pages. It could just be like a flat, I'm listing, so there's no other parameters that are going on. So for those classes, they won't have any actual properties as part of it. However, I'm still representing the intent of this operation as a individual class. So I still have a query class that represents this query for this specific page or action. I don't try to reuse some other one that says, well, let me just have a generic, I don't need anything query, because if this ever changes in the future, I want to make sure it's only affecting this one page and not affecting anyone else. Of course, I can have parameterized queries. So if I have query parameters in the URL, then these would be represented as properties on this query object. And often we can even use the same query object as the thing that gets bound to from the input parameters if we want. Or it could be even more complex. If we have a very complex search screen or like paging, sorting, and filtering, these input query objects could get pretty complicated. Now, what about the responses? Now, these responses have a purpose and have an audience and have a intended use case. So I'm never developing these queries, the handlers, the responses, the requests, the models. I'm never developing them in a vacuum or developing them and kind of trying to guess or whatever. It's really designed for a specific use case in mind. And really, it's like I get a user story. It says I need a screen with these parameters, with these form fields. So, these are the fields I'm going to be showing on the screen. So these queries, handlers, and responses are really designed for something tangible at hand. So this one, I have a response, but this response is being consumed by a view. So this is like traditional MVC. If we're doing APIs, then the response would be the model going out the door as JSON. In this one in particular, I'm looking at all the different fields being shown or being bound to the screen. So I say, okay, well, there's this thing, which is the kind of current filter. There is all this junk here at the bottom that I'm passing over to the view. And so my model itself is going to be just the fields I'm showing on the screen and nothing else. So this idea also came from this idea of building on view models, where I'm building specific DTOs for views on the screen. And those are really dumb DTOs that they aren't connected to a domain model, have all the kind of baggage that comes along with that. It is something that is just the data being shown on the screen and nothing more, nothing less. So sometimes it could be simple. So just straight properties as part of it. This one's just like a flat list of fields on a screen, but it could be more complicated. So this one has kind of like a parent information, child information, where I'm showing some summary information, but also maybe there's a table on the screen, so it shows a list of information. But one of the things I'm doing here is I am scoping that set of child details to the parent response, because for this screen, I'm not necessarily like sharing a control or sharing a table with anything else. So I want to be very explicit about the information I'm showing in this screen and modeling my DTO to be only the information being shown on that screen and nothing else. And that includes any kind of child data we see here. So that's why you see here that I'm scoping this child class or this inner class to the parent class, because I'm explicitly designing the fact that this child, this inner class, is only being used within this context of this request and not anything else. All right, so we got the request, we got the response. We will also need the actual logic of the handler. So that's the next part. So this one it kind of depends on your existing data access logic itself, like what you're doing as part of that. On our projects, we're using AutoMapper. So this would be, in this case, it's a simple projection. So I'm taking my DB context directly, projecting it to the model. So this is using a select projection. And when I call toList, it will take that projection and build out the explicit SQL, only what's actually necessary behind the scenes to populate the DTO. So this also resulted in our ability, when we're building these smaller slices, we could optimize our individual queries per use case and per slice, so that if I am only affecting the change of this one single handler and optimizing the query by itself, we now have the ability to really make sure that the queries we were building for each individual use case were not going to affect any other use case with respect to their optimizations. So we could do something like raw SQL if we wanted to. So I could say, for this one use case in this one slice, it's more complicated, and it's too complicated for an ORM, that it gets into like way too many, oh gosh, I know I've seen some crazy EF joins and stuff that make the DBA cry. So we said, okay, well, for these more complex ones, instead of resorting to stored procedures, we can also just do inline SQL that still, is secure, doesn't have any kind of, OWASP problems, that we're not having any kind of SQL injection attacks, anything like that. But because we're encapsulating at a per request level, I am now enabling our developers to optimize each request individually, as opposed to a layered or encapsulated approach, where it becomes much more difficult to say, how do I optimize one query versus others, especially when we have like abstractions preventing us from doing so. So we could do whatever we want, really. We could do ORMs or micro ORMs like Dapper. Maybe we have to call an API, or maybe it does have to call it to that old like SAP web service, something or other, to do whatever it needs to do. Because each individual operation is fully encapsulated from the others, we don't have concerns leaking from one individual operation to the other. Now, that's not to say that you should do this. Like, I don't allow my teams to just pick whatever they want, to say, today we're going to use Dapper, tomorrow we'll use NPOCO or Petapoco, and the next day we'll use a document database or whatever. Like, there still has to be some thought put behind this, but the idea is that you're not forcing yourself into that coupling early on. You allow yourself to make changes for each individual request as needs arise. Now, in queries, it is less common, but it is possible to have duplicate logic amongst different handlers. So a good example is like, well, I have to get the list of approved invoices, and then I have to go do something based on that. And maybe that individual query to say, give me the list of approved invoices, is common between different classes. So this is, I treat this as sort of normal code smells from way back, like the fallow refactoring days. To say, okay, I've got a code smell. It's copy pasted code from one class to the next. So I need to figure out what makes sense in order to refactor that code into some single common location. Now, in terms of what that looks like, it really depends. So some of my teams that I work with have lots of duplicated queries that they need to put into some encapsulated location. So they'll provide another level of encapsulated kind of domain queries or database queries that can pull that common logic into some single location. I don't have a lot of prescriptive guidance here, because it does rely on us, kind of relying on understanding what is the nature of the duplication, and then what makes sense in terms of how do we pull that logic out into some common location that can be then shared explicitly amongst individual handlers. All right, let's talk about commands. So commands are kind of interesting in that there's the opposite of queries. So while queries very often had very few parameters coming in, commands are the opposite. Commands will have a lot more parameters as their inputs because it's all the information that the user is typing on the screen. So if I look at something like this where I have a model bound type that has all the different pieces of data being shown on the screen, and they can edit, then each of those different pieces of data will then be different properties on my input command object. So that also means that I'm no longer binding myself to domain objects, and we shouldn't be doing this anyway, right? Like our input objects on the model bound objects for our UIs should not be the domain models, because that opens us to all sorts of security problems. Instead, what I do is I model my command objects, my command DTOs, based on the individual requests that are happening. And this is especially helpful if I'm doing task-based UIs, where each individual operation the user can perform is represented by its own kind of link and form based on the screen. So I don't have like generic edit screens, but instead every single operation the user can perform is its own sort of micro form instead of validation logic and everything according to that individual operation. So in these kinds of UIs, every single operation the user can perform results in a separate request, handler, and response object for all those different operations. Now the responses are also interesting for commands, because oftentimes there's not necessarily a specific response that happens. So if you imagine I have a button on a screen, I click the button, the kind of feedback to the end user is usually just like, well, you have a validation error and then success or fail. That's pretty much it. Either succeeded or it failed. So it could happen that there is nothing that you get. The most you get is an exception if something goes wrong. But otherwise, we assume that it succeeds because of validation, but the actual handler itself doesn't have anything in return. It's just, if we kind of assume success, and if there's any failure, it'll result in an exception. But we can also return a response if we want to. We can do things like return success fail, just did it succeed or not? Or we can do things like return a GUID, like we were creating something. And so the result of the creation is the ID of the thing that was created. And so then we can then surface that up to the user as like a 302 saying, yes, I've created it. And here it is. Here's the ID of the thing that you created. Or you can get bonkers with this. So you can say, okay, well, we actually have very complex responses that have a payload that is, here's the result of the thing that you did. You may have a failure reason or reasons, and then we tell you success or fail based on that failure reason. And to make our lives easier, we may do some like operator func to say, make it, if result, then we can say, it's successful or not. This is probably the most complex I would get. Like I've seen folks get even more complex than this, but this is one of those patterns I only introduce when the need arises and not before, because it can become annoying to deal with on every single request of like, now I get to fill out a reason of why it failed. How do I surface that to the end user? How do I show validation errors? I tend to hold on these more complex result patterns until the kind of the business needs arise. So just because we have our commands and queries separate from each other does not mean that there's not some sort of relationship. And very oftentimes you see the output of one go to the input of the other. So in this case, if you've got an edit screen you're showing to a user, the edit screen is showing a form, but the form represent inputs to a command. So if I'm editing something, the query output is really like the blueprint of the command. And then once they finish like modifying that blueprint, then that becomes a real command request that then goes into the system. So I often find this, that it's okay for us to sort of share, quote, this object, because I'm showing a form on a screen that represents now the input to be able to perform that operation. And what about the handlers? So this is the the part that most people skip when they're doing this kind of architecture is really understanding how they should model the handlers. Most of the time, I start with just procedural code. Just do the simplest thing that could possibly work. And that's it. The handler itself as well isn't doing any sort of abstractions on its dependencies. I only introduce these abstractions when the pain arises or when the need arises, not before. So my handler is directly using this case entity framework and automapper simply because I want to be able to leave the door open for any kind of refactoring in the future. And that becomes easiest if I don't introduce any abstractions ahead of time. I wait until the need arises, and then I will introduce targeted specific patterns and encapsulations for those abstractions that I need. Now, we've moved away from these single service manager helper objects that we know are bad because they're so big and so long. But we can still have the problem that these handlers become complex. So when these handlers become complex, because they will, don't panic. Remember the old friend, Green Refactor from TDD days? Although most folks skip the refactor step, that's the main problem I see with this approach is people skipping that refactor step. But I still encourage my teams that when they're doing this architecture, because I'm starting out with the simplest code that could possibly work, which is TDD, they can't skip that refactor step. And the refactor step involves investigating the code smells that I see in that handler class and then deciding, do those code smells warrant a refactoring? The two biggest ones I see often come up are large class and long method. They're basically the same thing because I have just a single class with a single method, so it's really the same refactorings there. And so I have a lot of options here about how I can refactor that code. So all the refactorings in the Fowler book, these are available to us to be able to pull out and refactor our code and make the code easier to understand. But the two ones I use the most are at the bottom, compose method and extract method. And then finally, if that logic becomes too complicated, then I use move method to move my method to another class somewhere else because it's too big here, or maybe I need to use it in multiple places. But these are just kind of the simple code smells that I see out there. There's another great book for patterns and code smells and refactoring, which is the Refactoring to Patterns book. This one is, if you hate design patterns, it's probably because you thought of them as like a checklist, or you had a developer on your team get really like pattern happy and be like, oh, look, I did the bridge pattern, which I've only seen in real life exactly once. But this book is great in that it actually starts with code smells. So it's using code smells to identify problems in your code and then using design patterns to solve those code smells. So rather than viewing like a checklist of patterns to go from, and more says, okay, I've got this really complicated switch statement. How do I refactor this switch statement into something that isn't just smaller methods, but perhaps a design pattern is a better way to represent concepts that I want to represent here. So these are some of the common behavioral smells that I see, but a lot of times it's like complicated combinations or complicated conditionals. I have times when I need common logic or duplicated between other ones, or even more complicated ones where I'm looping through something, but as I'm looping through, I'm doing different things. So I keep all of those options on the table available for me when I run into these more complicated code to say, where should this code belong? How should I refactor this code? This is the hard part of this architecture, is I need to figure out, once I've got that first set of code written and the test passes, now, based on the code smells, where should I refactor this code to? So one example is just like, okay, long method. Okay, we've got a long method with a lot of code inside of it. Usually the first thing I do here is simply extract methods inside of this class. So I will create smaller methods that represent each of the different kind of major operations that are getting performed and first just make smaller methods that each one of them is performing kind of the one operation, and see if that makes sense first. Now, if I want to then take that next step in this giant method here, what I'll often do is say, it looks like a lot of this logic is really dealing with these domain objects. What I should instead do is push my behavior down from the handler, so the handler's doing as little as possible, and then really I'm pushing the logic down into the domain objects, and the domain objects are really doing the bulk of the business logic. So as I see larger and larger handlers, I'm pushing more in my logic out of those handlers, so the handler logic becomes really simple. It's really just like data access code, delegate it to the domain, and then data access code to save it. So it's like load, domain, do your junk, save it, done. I'm still not done necessarily. So even if I get inside the domain objects, I'm still looking to see, is this logic too big? And perhaps I still even go further to say, let's refactor these methods down to smaller and smaller things. So this kind of operation, where I start from procedural logic and I use code smells to push domain logic down into my domain, this is what results in an encapsulated unit testable domain. I'm not yet found that this is something that arises naturally. It's something that has to be worked towards actively by using refactoring techniques. All right, what about validation? Validation is something I always have to deal with, especially in commands, that I don't just blindly perform whatever operation that users are doing, that I need to validate and make sure that I'm able to perform this operation and then go on from there. But I often find there's several different kind of levels of validation I need to perform. There's the kind of top level request validation. That is, in the individual request, I'm looking at only that one request object to determine if it's valid. But then there's the overall operation itself. And this is command validation, where I'm saying, based on the context of the entire system, is it okay for us to perform this request? So the request validation just looks at the class by itself, and the command validation can look at then the entire system for whatever that means for system. Request validation, you can do whatever you want here. I'm showing here fluent validation because it fits nicely with the this kind of CQRS kind of idea of vertical slicing, because I can build validators for each of my requests, but you can certainly use other frameworks like data annotations validation certainly works as well. But the idea here is that for the request validation, I can only look at myself. I can only look at the request object. I can't poke out to look at any other things. So if I need to look at something else, then my validation strategy does need to change a bit. So one example we can do is domain validation, where we're using these result objects. So this is something that I have to look at the actual loaded up entity from the database to say, you can only perform this operation based on the context of the whole entity, not just based on the form you've submitted. So in this case, this is like, oh gosh, approving an order. The command to approve an order, though, would just contain the ID of the order you want to approve. I don't have the rest of the information at my disposal to say, can you perform this operation? So if I need to load up additional context, in this case, I'm actually encapsulating that validation in my domain object itself. I can look at the domain object aggregate and say, okay, based on the entire context being loaded up, let me go ahead and return a success or fail based on the entire context of the system or this aggregate, whatever the context is. All right. Now, so far, we've talked mainly about the different kinds of, this is like more like a server-side MVC, but that's certainly not the only way we can build out these response objects. So we may have cases where we're going to share responses amongst multiple sort of requests. And I look at that as sort of the RESTful representation style, where my response feeds into something that is a representation for that information on the screen. So my response could be passed to a view. So in that case, like my controller then becomes just a route to to views to be able to show the information. And so my query inputs and objects represent individual kind of requests on a controller action. Or if I'm using something like Razor pages, then each Razor page is its own individual request in the system. And so the Razor page then is sort of my representation of that individual slice. So I've got like the data as part of that as well. Or if I'm on an API, then it could be the case that I expose multiple API endpoints, each with separate handlers. However, from the user experience perspective, they're still on the same screen. So they always get kind of like, okay, I approve the request, and then I just show the same overall screen to the end user because it's a SPA or whatever. So these all might actually return the exact same response object because they all feed into the same overall SPA. Now, one of the things that we found as we were building out these systems was we were starting to see duplication across different handlers, different requests, and different responses. And sometimes this duplication was just simply common domain logic, and so we knew how to refactor that. But sometimes it was really cross-cutting concerns that we were literally copying and pasting code on every single handler of a different kind, like different commands or different queries. Now, initially, we just used the DI container to encapsulate those cross-cutting concerns via decorators. But we ran into the issue that we were relying on the features of DI containers to do those decorators. And I started getting angry emails from those DI container folks to say, people are abusing my DI container to do all sorts of crazy things that they shouldn't be doing. And so instead what we wound up doing is explicitly modeling these cross-cutting concerns as behaviors. And these behaviors are part of a pipeline that decorate the handler when you pass off the request to the mediator before it actually goes down into the handler itself. And these are kind of like a Russian doll sort of thing, where I've got a handler with the actual business logic, and then outside of that, I start to have the different behaviors I'm stacking on top of all the kind of main requests that happen in my system. And so those are really similar to middleware. So think like action filters or request delegates for HTTP clients. These are things that happen basically outside of the handler, but happen on every single time I'm delegating off to one of these handlers. So some examples we saw that we've used these kinds of, every time I get a request, do this certain thing, or maybe things like transactions. So we knew that every command should have a transaction, but our developers would forget to put the transactions in there or not be explicit about when the transaction should occur. So for these, we said, okay, we're going to have a behavior in this system that says, instead of it being an implicit transaction where you don't really know when it's happening exactly, instead we'll be explicit to say around all of our commands, we're going to have a transaction that's before you execute the handler, we'll open the transaction, and then after you execute the handler, we'll commit the transaction, and then if something goes wrong, we'll roll it back right there. Or if you're using a unit of work pattern, we've done this with ORMs or databases that don't support this kind of don't only have the unit of work built in. Then we'll say, okay, I'm going to execute the next action, and then once that completes, then I'll go ahead and complete it. We've had cases where we need to do retries or check for concurrency violations. So we're using Mongo at one point, and we wanted to we wanted to handle concurrency exceptions, and so we catch those explicitly and say we'll go ahead and retry those like some certain amount of times, and then after n number of times, we'll go ahead and say, okay, nope, we retried too many times. But a common one, of course, is like logging, to like log all the requests, especially the not the HTTP level, but like the one level below of the request object going in and the response object going out, then we would log that as part of our system as well. So it wound up looking something like this in our system, where we would have cross-cutting concerns for things that need to grow across all the different features. Those then would delegate off to the individual feature slices, which would then rely on some common shared persistence layer for all the different pieces. So we'd have domain agnostic cross-cutting concerns to the behaviors at the top, but then we'd have domain specific logic in each of the different features. Where as much as possible, we would push that feature logic down into our domain itself so that that logic could be independently tested and, unit tested and modeled there. So just some key takeaways as part of this. By building our application logic in this way, it makes it really easy for us to add, change, and delete code, mainly because we're really, in the systems like this, when we're architecting where new features are always built as kind of new code, it means that it's very easy and quick for us to add new code in our system. The developers that are adding code don't have to go back and look through and say, oh, wait, this service class is being called by these other service classes, which is being called by these other screens, which is called by these other use cases. And they spend the bulk of their time analyzing the side effects to the system. With this kind of architecture, we're intentionally designing architecture to avoid side effects and avoid coupling from the get-go. But this also does mean that because it's not prescriptive in its guidance about where exactly logic should belong, that we cannot skip that refactor step. That we still must look at the code smells as part of those handlers and say, based on those code smells, where should we push this logic to make it more easily testable, more easy to maintain. So yes, push that behavior down. And then finally, because we've avoided abstractions, we've avoided these kind of like service interface explosion where everything's like an I something service, and then there's just an implementation. It does mean that we don't have a lot of mock heavy unit tests. So because of that, we need to rely more on the integration tests for our handlers, and then the unit tests now are part of that individual domain. So if y'all want to learn more about this, of course, you can check out my blog at jimmybogard.com. We've also got an upcoming training course, which is in a month and a half or so. And for folks on this tech excellence, I've actually got a voucher code for a discount. So if you go to that bit.ly and use that voucher code, you can get a 20% off discount. Otherwise, if you do have more questions about this, obviously we got the next 30 minutes. But you can also ping me on, I'm not going to say X. You can ping me on Twitter. My DMs are open there, so you can ping me there. Otherwise, I thank you all for joining me this morning, afternoon, wherever you are in the world. And yeah, look forward to the questions here.
Thank you, Jimmy, very much for sharing this session with our community. And we do have some questions here. Let me bring them here. Let's start with this one. Following the same reasoning to separate service methods and classes, what about input validation? You mentioned this shortly, but maybe we can discuss it a bit in depth. What about the input validation and business rule code? Should they be individual classes or should they be part of the handler code?
Yes, so I tend to break those out into individual classes, but just organized alongside the handler code. So I still try to follow the sort of single responsibility principle, except those single responsibilities are now scoped to each individual slice. So we saw a little bit there, those like blah, blah, blah validator, but anytime I want to break out that logic, I still kind of keep it together as part of that slice. And only move it to some sort of shared location if it is truly intended to be shared amongst multiple use cases, operations, slices in the system.
Thank you very much. Oliver, do you have any additions? Okay, great. Let's move to the next one. Sometimes security teams recommend you don't return IDs from created elements. What is the recommendation to deal with that, keeping in mind this is imported in the API's context?
Yes, so this doesn't really have anything to do with vertical slice, which is okay, but it's something we commonly run into here with this kind of architecture. So what the security teams are really recommending is to not return an easily guessable ID from the database. So like don't return an identity column that's a identity numerically increasing column. So for those kinds of requests, what we'll often do is have like a separate ID that is a GUID that is something that I do expose to the outside world, but it means that they can't guess the IDs of other things in the system. Now, security teams, they say like, don't return an ID. What they really mean is don't return the primary key that is a number. So usually it's a conversation with them to say, yes, we're not returning the ID, but we have to have some way to identify this thing. So it's just not the primary key. It's something else that is also unique and indexed, but it's just not the numerical primary key.
So many more questions just came in, so let's pick the next one. Thank you, Jimmy, for your answer. Let's pick this one. What are your thoughts on having multi-modular projects to segregate core, common domain as separate projects, vector models, and all reference from controller in different module?
Yes, so in this kind of architecture, there are going to be things that I intend to share across the use cases in my system. And a great example of that is my domain objects, right? It's if I've got 3 operations in a system that's like, I need to approve the invoice, I need to reject the invoice, or I need to cancel the invoice. Well, those are all probably dealing with invoices. So the invoice thing needs to belong somewhere. So in my systems, I start out with folders as a way of organizing my common shared code that is between different slices. So I would start with domain as a folder in that application. This is just my personal preference. I only create projects or separate modules or assemblies when I'm forced to, based on the deployment architecture of my system. So if I have 2 applications that have to share common code, then I put that common code into that common spot. I don't do that until that need arises of having like 2 applications that have the common code. So that goes with any of those kinds of things that you mentioned there, core, common, factories, whatever. I only move code into a common location if the use case arises, but not before. Otherwise, it stays in its slice because it's only meant for that one slice. If it's meant for multiple slices, then pull it out somewhere else. I don't pull it into a different assembly until it's meant for multiple applications or multiple deployed consumers. Yeah, Agni, right? You're gonna need it. So like, don't do it until the need arises. It kind of goes back to that whole thing.
You also mentioned about refactoring, but you don't refactor until the need arises. What is the right time for refactoring? When do you feel that the need is there?
So every single pull request I review with my developers assumes that the developer has made that analysis of the code they just written. So we may not follow a very strict red-green refactor. Maybe the green is like, maybe there's no red, but there needs to be at least an analysis to refactor with every single feature we're developing. That's just something I expect from my teams. I don't expect them to say the first code that got vomited out of my fingers onto the keyboard is what I then submit for my pull request. I expect them to take that step back and then look at the code to understand, is there any code smells I'm seeing here, any refactoring opportunities. We also do have like, I as part of a tech lead role, I am keeping an eye on duplicate code across slices, because a developer may not know, like, oh, this has happened in 2 places. Instead, it's something that is sort of a ongoing analysis effort to say, is there common logic cropping up in multiple places? This will come up. Those kinds of things often come up in discussions with a business, where either a bug comes up and they say, oh, this should have been the same way done over here, but it wasn't. Or just part of our discussions that, we both know that, similar operations are happening over on these 2 sides, or these 2 screens. And we bring it up to them like, okay, should these be the same? Should every time I make a change over here for this piece of logic should also affect this other place as well? And make that to be a business decision that, yes, indeed, these should be shared, versus if I'm going through a strictly layered approach, then it's accidental or maybe not intentional on the business side that says those should be the same. But in terms of when a refactor, I'm always analyzing on refactoring. Like every single feature should be looked at to say what code smells are being exhibited here, and should there be any refactoring done as part of that. That's just like, that's any system I'm working with. Anytime I'm touching the code base is an opportunity for us to make the code base better than when we left it.
As you see here, Matthew supports us on the refactoring idea. So you also touched the testing topic. Peter writes, I really like no mocks and more integration like unit tests. What's your opinion?
I didn't get into it too much in detail on this presentation, but we did notice that our testing pyramid started to get a bit more square-like, or wasn't necessarily inverted, but it had like more of a wider base. I don't know what shape that would be. But yes, so what we just said was every single slice needs to have an integration test, because that's the ultimate, it's the ultimate kind of, I guess, test to know whether the feature is done or not. So to be able to say, I'm going to push a request in, the handler executes with the full set of dependencies that we can control, and then I look for the response on the way out. But I don't care what goes on inside of the handler. We've got just sort of more of a black box integration test that tells us kind of the ultimate pass or fail whether there are whether our feature is done or not. We still do have unit tests, but much less of these like mock heavy, especially when you have very layered applications where every single layer mocks the layer below. And so you never test the system as a whole. It's only testing the mock of the layer below. But we kept finding over and over again that those are the tests that were the most brittle. They would pass, and then when we ran the system, it would fail. Or if I was trying to refactor something, I was having to refactor a bunch of tests to say, oh, this method doesn't look like this anymore, so you have to go change all the tests to mock that set of code out. So as much as possible, we try to go back to I think it's more like what Kent Beck was trying to get to with his description of unit tests, that units are not a class with mocked out dependencies. It's a bit bigger in scope. So we said, for us, we even stopped calling them unit integration. It's like slow test and fast tests. Our fast tests were all the code that was in memory, and the slow tests were things that had to call things out of process. But unit integration, what's unit, what's integration? It was just like in memory, out of process. Those are the 2 sort of tests we had. But it's like really as much as possible, our tests should enable refactoring, not prevent it. And if we found tests that were overly mock heavy, that would actually actively prevent us from refactoring. And so we got rid of those. So no more of these like heavy mock, everything is just a fake. Instead, build tests that enable refactoring.
But you don't use many unit tests for handlers due to abstractions, because you mentioned quickly before that you don't use many abstractions in your handlers. Did I get it right?
Yes. So because I'm not abstracting the database or abstracting anything else, then the integration test is around the handler. I don't unit test the handler, which also means if I want to unit test the business logic as part of that, then I should refactor it into code that is unit testable. So that usually means, that's why I do the data access code first. That gives me a thing. Then I delegate that off to like a domain service or whatever to do the actual business logic. But at that point, the data access is done. I don't have to fake or mock that out. And so I'm really just trying to mock that out. Sometimes it gets more complicated. So like, let's say I'm having to do multiple levels of queries or whatever. So in those cases, I'm still like pulling the logic out into places that are more unit testable, but I'm really driving that through code smells and refactoring than trying to introduce an abstraction, because I still have to write the integration test. Like I still have to load up the real thing from a database, because ORMs are like some of those complex pieces of software on the planet. And so I can't skip that step. I can't skip the integration test step. So I only write the unit test if there's something that I can't pull out somewhere else, and it's too like whatever. So yeah.
Thank you very much. Oliver, do you have any additions to this discussion?
Well, I mean, what you say over and over again is that you need to keep track of it. You need to really think about your design. Like every time you make a change, you need to think about, do I need to refactor this? Do I need to refactor that? And from my perspective, I see lots of teams that can barely extract a method automatically. So my question there is, I mean, it sounds like, it sounds absolutely reasonable for a team with like 10 plus years of experience. Everybody knows all the code smells, knows what feature envy is, knows how to refactor very quickly, and does that regularly. But what I see usually is that this step is omitted because people don't know how to do it, and they just don't do it. And then they take the vertical slice architecture and say, well, they don't need to do any refactoring there, and or they just skip it because I don't know why, and they just have abstraction-free architecture, and then you get back to the big ball of mud, in my opinion. What do you think? Or what's your experience?
Well, it's more of it's a pile of smaller pieces of mud, really, in that case. Yeah, so I don't know. I've gone both directions. So I haven't done clean in a long time, but we started out with the onion style, and so we had a very big separation between business logic goes into a service, and then data access logic goes into a repository. But inevitably, we found that the services still got big and nasty. So this later approach didn't save us from a big ball of mud. The only thing it did was add coupling. So we still, even with all this kind of prescriptive guidance, there's still the case where logic is going to get complicated in these like very well-defined boxes, and we still have to perform that sort of refactoring step. I just don't think it's possible for us to enumerate all the different kinds of primitives, patterns that things should belong into ahead of time. We have to have this sort of design step, and sometimes it never fits in any of these boxes. And so I try as much as possible to leave the door open for the developer and the team to be able to take what's there and extract a design from that, versus trying to be very prescriptive up front. But again, this is one of the reasons why I still like to have this, as someone that knows what they're doing as part of this, to have that sort of design view and design focus. It's not something I just say, this is a way for us to create, a bunch of little balls of mud with a bunch of procedural code. It is still something that I stress to my teams. You do need to go that extra step, and pay attention to those code smells.
I absolutely agree. I mean, I would love every team to exactly do this. Think about your design, not just do something prescriptive. I just see that most teams are not able to. But thanks for that for that answer.
Thank you very much, both of you. Let's move on. And here's a question: if you have any tips on migration to vertical slice architecture for clean or end tier?
Yeah, so one thing I do want to clarify there, that this architecture isn't necessarily an either or from those other styles. Like you can still do like interior/clean with vertical slices. And in fact, if you go to YouTube and look up clean in the .NET space, they're also all recommending vertical slice as well. The slight difference here is that I just stay away from the very prescriptive nature of clean, just because I find it's we still need to perform this sort of refactoring step. Nothing's going to save us from having to do thoughtful design. So in terms of tips for any kind of refactoring, anytime I'm new at an application and I don't understand how the application code is structured, one of the first things I do is do a defactoring step. So defactoring is just reversing the refactorings that have been put in place. So if I find like I don't like all these methods are organized in all these different places and I don't understand how the pieces fit together, what I'll often do is reverse all those steps for a single slice of a request. So I defactor, meaning like inline methods, inline classes, inline until I get back to like all the logic is just in the controller action or wherever that top level place is. Then I can take a step back and say, okay, what is the nature of the work being done in the system, and then say, okay, now we can go forward from there. But in terms of overall tips on migrating, any kind of architectural migration process should be something that the entire team agrees upon is something valuable to do, because it would take work. And then the other thing I recommend to teams is make sure that this is a process with an intended completion. That it is not something I say, I'm going to refactor 3 or 4 controllers and then abandon it. And then someone else comes in and like, why are half of them look like this and the other half look like this? It should be either I'm moving towards a specific architecture, or I do an experiment and it doesn't work and I roll that back. But I value consistency of an architecture in an application. I don't like coming in and seeing 18 people's different opinions about how the system should work. I like to see consistency. So if you're looking at migration, make sure it's like a migration process that either fully completes or fully rolls back, that it's not, a developer's opinion of the month.
This makes a lot of sense. And Marcus, really liked your idea on defactoring.
Yeah, I do a refactoring talk as well on this, like refactor defactor, and it winds up just being like an advertisement for JetBrains products, because they're the ones that their tools are really good about being able to refactor and defactor effectively and safely.
Okay, let's move to the next question. Any tips to avoid the shared domain using slice architecture or feature architecture?
Yes. So you don't have to have shared objects between different slices. I often find it advantageous to, because I'm repeating a lot of sort of stuff, but I have seen teams that are like, let's say they're pure Dapper, for example, where they don't share those kinds of things. So you'd have to really make sure that your frameworks you're relying upon for like persistence and data access lend themselves well to not sharing those pieces across different slices. I tend to find that there's not a ton of value doing that. Like it usually is the case, even if doing a document database, it's usually the case where there are multiple operations all dealing with like a single entity in the database. So I would likely want to represent that entity as a single object. You don't have to, of course, right? We could just write all stored procedures if we wanted to. And then there's no objects. It's just parameters into the database. But there's eventually some kind of shared thing, like a table, that would be across multiple operations. It's really up to your team in terms of how they want to model that. Personally, I don't want to go back to the stored procedure days, but there's a reason why we've gone towards like this object model, whatever.
Thank you. Let's move to the question of Sergey. How to avoid creating another repositories when extract DB interaction logic from your handlers?
That's a great question. So I'm gonna, instead of calling it a repository, I would say it's like an encapsulated data access object. Because a repository is a very specific pattern, and it could just be the case where, like, I mean, we've got two classes that have two sets of code that look very, very similar or exactly the same. So one way of extracting that would be to say, maybe there's just a common location for any code related to that kind of thing goes into one place. So a good example of this would be like a repository, where I've got different ways of querying orders over here and different common way of querying orders over here. So I move both of that common logic into an orders repository. But that's certainly not the only way you can extract common code into a single location that could be shared in multiple places. So data access code in particular, I guess even business logic, right? I try to avoid these generic objects that aren't specific for an intent, responsibility, and operation. That they don't describe a specific thing they do. They just describe like a kind of operation that could be represented. So, example, I try to avoid things like order repository or order data access gateway or order whatever. I try to avoid order service, order manager, because these are dumping grounds of logic for all sorts of different things. Instead, I will explicitly model the operation that piece is performing into something that is that one specific encapsulated request or operation. So instead of an order repository with a method for get approved orders, instead I would have a get approved orders query object, and this is a specific query object for that specific kind of query, and that is just that one class that represents that one encapsulated operation. Similar, if I've got complex business logic that is around approving orders, I would not create an approve service, or I'm sorry, an order service with an approve method in my domain. Instead, I would create an order approver that represents the responsibility for that encapsulated set of logic. That piece now can then be shared across anything that needs to approve orders, instead of going, well, I'll just load up the approve service that has all these different operations as part of it. So I try to encapsulate any kind of logic, whether it's data access or whatever, encapsulating that into classes that are very focused of that individual responsibility, as opposed to common, like, generic service manager repository classes.
Thank you. I guess it's addition to our previous discussion. Is it important for you to have consistent code styles between slices?
Yes. So, like, not just important, it's like essential. I do not want, this is maybe just me being annoyed as a tech lead for so long, is like, I cannot stand like individuals' opinions leaking themselves into the code base, because the code is going to live longer than any of them going to be at the team or company or whatever. I see code bases that are well over a decade old, and it just annoys me no end when I see like clearly someone read a book and got really happy about set of patterns and injected their own opinions into this code base versus sticking with the existing established style and kind of the established style and architecture. So yes, I make it a point on these teams to like, we need to have a consistent style and approach. Not every handler needs to look exactly the same, but I've seen things where like, someone decided in this slice that they really like mocks, and so they have this really heavily factored set of code that's like 20 different folders of every single method is one line long, blah, 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 factories and services and managers, and the other one is not. So I, as much as possible, encourage a consistent approach and consistent style across my slices. This is not an excuse for developers to just like do whatever they want for any single slice.
But is it not one of advantages of different slices that you could use different architectural patterns depending on the needs of this slice?
The goal is really around encapsulation of the logic behind it. So if something got too big or complex, it could, but it wasn't permission for the developers to do whatever they want whenever they wanted. Similarly, like, I don't know, microservices had the same kind of promise that like every microservice could pick its own stack. So this one's Rails, this one's Django, this one's Go, but then someone has to maintain all this. And so we don't want to have like just a cornucopia of different approaches. We still want to have some consistency. So oftentimes what I'll do is like still have blueprints for my developers to say, if you can have a simple one and that's just procedural code, it looks like this. If it's more complex, we push the behavior down into our domain and it looks like this. And if it's anything beyond kind of those two things, then let's talk about it. Let's look at your code and let's figure out a good design as part of that.
Thank you very much. We are running out of time and having lots of other questions. Let's bring short answers maybe to the most important ones. How do you communicate between slices? Are you supposed to use in-memory messaging?
Yeah, so this is, when I talk about like the slices represent requests from the kind of end user or use cases. So like users performing this operation, users performing this operation. If users are performing two different operations, or like the same users performing two operations, there's no communication that needs to happen at the application to begin with, because the user performs an action, wait for results, then they perform another action. So those two actions are separated in time. Now, if there's logic that needs to be like handled or communicated across slices, so a good example is like, oh gosh, whenever I approve the order, then I need to decrement the stock. So there's a number of different ways I could approach that. I wouldn't necessarily say that's communicating between slices as much as I have change that need to affect in a separate area of the system, and what are the most appropriate ways for me to affect that change. It could be as simple as in my handler logic, I do it procedurally, approve the order, decrement the stock. It could be something like I do, like you mentioned, in-memory messaging, quote, where my aggregate raises a domain event, and then I have a domain event handler that then goes and then decrements the stock. So this is just moving away from imperative coding to more of a notification style, that instead of me directly calling into the thing, I raise an event that says something has changed and then remove that coupling from one to the other. This is still happening in the context of a single request. So it's just a question of which style makes more sense to me. Is it more of an orchestration, or is it more of a choreography of the different ways of affecting changes into basically two aggregates or two areas of the system? But I don't really have two slices directly. It is more, that's almost always happening at my domain layer.
Mm-hmm. The very last question I would like to bring today: where should we put code to add or remove aggregates when we move away from repositories?
Sure. So that really depends on my data access framework. So, and really what you're talking about there is I'm moving away from the abstract repository concept, because like Entity Framework already implements the repository pattern, already implements identity map, already implements unit of work. So in those that already implement it, it is dbcontext.dbset.add. That is add aggregate. So it's not putting code to do it. It's like just use the tool at hand. Mongo doesn't implement these patterns, and so Mongo, I do like its client libraries don't implement the repository pattern. So I wind up implementing the repository myself. So I just say, I'm not moving it somewhere else. I'm using it, using the repository that's available for me. But in terms of the abstract one, I just use the use the framework directly. If it already has it. If it doesn't, then go ahead and add that in.
And that was the last question of today. Thank you, Jimmy, very much for sharing this talk with our community and answering all these questions. You can check later, there are a lot of more. And learn how to deliver quality software faster. Stay with us, we will bring a lot of more great sessions. Have a nice morning or evening. Bye.